All right, guys, let's try again on this lesson for inductive reasoning. So we are defining inductive reasoning as drawing conclusions from patterns and observations. A conjecture is the conclusion reached using inductive reasoning, and we call true or false being the truth value. So let's use some examples, and we're going to go ahead and write our conjectures. So the first one, we have our pattern is 38, 31, 24, 17, 10, 3, -4, -11, and -18. What we need to do here is decide what the pattern is, and in this case, to generate the next term, subtract 7 from the previous term. Number 2, we have 2, 5, 11, 23, 47, 95, 191, 383, 767. So what's the pattern here? To generate the next term, you will multiply the previous term by 2 and add 1. Number 3, our pattern is 1, 4, 9, 16, 25, 36, 49, 64, 81. What's the pattern? These numbers are all perfect squares, so to generate the nth term, square n, where n is just the number of terms, so the term number. Now I went ahead and included a little note here to say that n is the term number. For example, for the 15th term, n equals 15. Therefore, the 15th term is 225. Number 4, A, D, G, J, M, P, S, V, Y. Stop and think about what the pattern is. To generate the next term, you skip 2 letters in the English alphabet. Number 5, 7:30, 7:55, 8:20, 8:45, 9:10, 9:35, 10 o'clock, and 10:25. What's the pattern? In order to generate the next term in this sequence, you will add 25 minutes to the previous term. Number 6, the pattern is 3, 1, 4, 1, 5, 9, 2, 6, 5, 3. To generate the nth term, you will find the nth digit of pi. We have the first 10 digits of pi here. Now on this page, you may notice that I have things that are in different colors. The stuff that is in the green boxes is not a requirement for you to copy in order to get credit for the notes. However, it is some good vocabulary information, and if you think it will benefit you, I recommend including it. So on this page, we're going to talk about counterexamples. A counterexample is an example that proves a conjecture false. Please note, only one is needed. Although on here, I do give you more than one in many of the cases. So number 1, the sum of any 2 consecutive integers is always odd. We need to remember that sum is the result of addition. Consecutive means one right after the other. Integers mean positive and negative whole numbers. And odd is a number not divisible by 2. This is a true statement. Number 2, the product of 2 numbers is always larger than either number, where product is the result of multiplication. This statement is false. Multiplying by 0, multiplying by 1, or multiplying by a positive by a negative number will result in numbers that are either the same as the number or less than the number. Number 3, the product of 2 perfect squares is always a perfect square. In this case, we are defining perfect square as the result of multiplying an integer by itself. And this is a true statement. Number 4, if the area of a rectangle is 6 meters squared, then the dimensions must be 2 meters by 3 meters. This statement is false. The dimensions could be 6 and 1, or it could even be 12 meters and half a meter. Number 5, dividing by 2 always produces a number less than the original number. This statement is also false. Dividing a negative number by 2 produces a larger result. For example, negative 10 divided by 2 is negative 5, and negative 5 is greater than negative 10. Number 6, vertical angles are never complementary angles. We are defining vertical angles as angles that are across from each other in an intersection. So if you look at the picture here, I have the two blue ones and I have the two pinkish ones. They are always congruent. Complementary angles add up to 90 degrees. So this statement is false if the vertical angles measure 45 degrees. Number 7, if A times B is 0, then either A is 0 or B is 0. This is a true statement. Number 8, two angles supplementary to the same angle must be congruent. Because supplementary angles add up to 180 degrees, and to find an angle supplement, you subtract the angle measure from 180, you will always get the same result, and congruent means the same size. So this is going to be true. Number 9, all state names have at least 2 syllables. This is false. Main only has 1 syllable. And number 10, squaring a number and adding 1 will always produce an even number. False. 4 squared is 16. Add 1 and you get 17. So this is our introduction to conjectures and providing counterexamples. We will be required to provide a counterexample anytime we are claiming a statement is false in this class. So that's all I have for you today, and I'll see you next time. Bye.